Good. Well, thank you, everybody. This has been very, very informative, and I'd have to say the science and the experience that we've been hearing is absolutely vital so that we get this successful outcome that we're looking for. So what I'm going to touch on fairly briefly is going to be these main areas, that the challenges that we're facing in our environment is getting trees and stormwater into shared spaces successfully, sustainably, clean waterways, mitigating urban heat, and meeting urban canopy targets. So one of the challenges we have is we have this vision as designers for the green, shaded, well canopied areas for sharing, for the public to come and share. But we've got these other issues, and as has been touched on so well and so thoroughly, the space that a tree's root system normally occupies in its natural environment is already occupied by the built environment. And then we want to try and treat the stormwater and manage our flows, as the experts have been telling us. How to do all that in juxtaposition is our challenge, and the way our forefathers went about it has not been optimal. Clean waterways is another one of our challenges, and as we've been saying, so many of our trees have been planted in a way that the pavement, which is impermeable, is graded towards catch basins, road pits. The water goes into pipes where it's gathering velocity into a river system, and where we're getting flash flooding, turbidity, erosion, all sorts of issues. So how to allow our trees, how to grasp this opportunity of the trees in the cities performing a vital part in the stormwater treatment train is why we're here in this room at the moment. And mitigating urban heat, as we know, is a challenge, is an issue. Some of our clients have actually heat mapped the city and are using that to guide them in the prioritisation of their tree planting program, which is great. So some of those bare laneways, and we know it's a challenge, and we've got to find ways of shoehorning tree pits that are also functioning to clean and help us manage our stormwater into those hot places. And we can use thermal imaging as well at a development level to guide us in placement of trees. And meeting urban canopy targets, as we know, and Australia is very well placed in this regard. It's pretty much at the forefront of mapping urban canopy and setting targets. And I know in one region in Australia there's quite a large fund being put aside to help the municipalities in the region achieve a certain canopy target, and the canopy has been mapped at a municipality level, so those that have got the lowest level of tree canopy are able to claim a larger proportion of the funding to increase their canopy. One of the things I want to talk about is another piece in this whole equation that has, I think, been underrepresented, is how soon can we get to those canopy targets. And we'll talk about a case study in a few minutes. So solutions we want to talk about is meeting the needs of the tree below ground, preserving infrastructure, and providing access to the rainwater. So soil volume we've touched on, and we've talked about rules of thumb. There's a bunch of them out there. Some really good work has been done by Leek and Hagi. There's an online calculator. I know that's being used here in Melbourne, and I know it's also being used in California. We've come across it being utilised in one of the big cities in California, is the online calculator for estimating target soil volumes required for a tree species. But it's so much bigger than what we've thought. But if we can allow for the life needs of our chosen tree species, we get the results quick. Some cities we see a shift internationally. A lot of cities worldwide have no target soil volume. Some cities, I know Melbourne does, City of Sydney does, have got a flat soil volume target. I know of one capital city that actually has their list of recommended tree species in the street environment, and against each species they have a target soil volume, which is really pleasing to see. But and please excuse me, some of this is in Imperial. I've just come back from giving this talk in the United States, but a really simple one is the 2-to-1, which is for every 2 square metres of shade that I want to provide, I'll give 1 cubic metre of loam soil at planting. And we'll pull that apart on a case study in a couple of minutes. And soil quality is key. We've seen too many projects that have performed less than what we expected because a low-grade soil was used. Soil is the secret sauce in tree health. A lot of what we do is just enabling soil volumes in trafficked areas, but the quality of the soil is so vital, and it's just really, really important. If you're going to invest, if you're going to have a long-term approach to funding a tree planting program, it's worth paying special attention to the quality of the soil. So soil vaults is what we're about, is providing enough soil volume of a quality loam soil to meet the life needs of the tree. So whatever method is chosen, we have a couple of methods, but whatever method is chosen, we've got to give enough soil beneath the pavement to provide for that tree's growth for its life. Now with rainwater, we want to allow trees to access the rainwater at source, and that's what this whole workshop has been around, is how can we do that? How can we do that successfully? We've touched on a couple of different methods and ways of getting water into the pit, and maintenance is obviously key. But we're wanting to reduce the load on our downstream infrastructure. I've spoken to some professors who've said that the constructed wetlands that we're building on development sites, they're not getting maintained the way they should be, within the cycle they should be. But if by intercepting water as the raindrops hit the pavement, basically with the tree pits, if that extends that clean out cycle from 10 years to 25 years, there's a tangible cost associated with that. In many cases, it may mean that we can meet the entire needs, mandated needs of the stormwater treatment with tree pits, which gives us recoverable land area. So instead of sacrificing land for open bioswales, we can actually create an equivalency beneath pavement. And that's key, particularly in our heavily built environments. And I'd just like to suggest, can we start with the tree, not the stormwater? What I'm showing here, I took that photograph last week in a city in Greater Los Angeles, and it's a device that's been sold as a tree pit, but it's actually a precast concrete pit. Now, I'm saying this is an attempt to design a tree pit starting from stormwater, but not starting from what the tree requires. So yes, it's convenient. Yes, as engineers, we understand concrete and we understand precast systems that can be craned into the ground. But this device here has nowhere near the soil volume the tree needs, and it's got a high flow media within it, and the water's going straight to where the root ball of the tree is or was in this example. And I just saw this and jumped out and took some photographs. You can see all the trash and the litter inside it. I would plead with you, please, can we consider 2 things here? We need to bring the water in away from the root ball of the tree, so that we're not dumping all the pollutants that come off the road directly onto the most sensitive part of the tree's physiology. And B, we've got to look at soil volume. There's nowhere near enough soil volume there, and if you're going to try and grow trees in a rain garden, you either end up with no trees or a very, very limited range of trees that will even survive in that type of environment, because the water comes and it goes. We've got to hold the moisture longer for the life needs of the tree. Type of system we're talking about is where we're bringing in water high in the profile of the pavement, if you like. So we're leaving the soil down inside the vault. We're achieving ponding across the surface area of that soil, and it typically has about half the hydraulic conductivity of a filter media. So we're holding the moisture for longer. We do need more. We do need more area, but there's a bunch of different ways we can get the water in. But we want to bring the water in shallow through the back of the curb. Those curb inlets that we saw before, they're great. Permeable pavements, or if we're taking water off the sidewalk catchment, we can use permeable pavements, we can use trench drains along the back of the curb. There's a number of ways we can do it. But essentially what we're doing is we're bringing in our water at the top of the soil vault. And what we're seeing is, it's a very interesting juxtaposition, is that for tree health, as Gary touched on before, we're talking about volumes relative to the mature size of the tree. For stormwater, we seem to be talking in areas relative, surface area of the pit relative to catchment. And these are a few of the areas that have seemed to have arisen from this whole space as far as design. There's also community engagement, and we've got really passionate about getting the community engaged with this great work that you're doing. I just recently took this little plate with me to North America, and essentially what it allows us to do is to get the community engaged and supportive of what you're doing. There's a bunch of ways you can do it, but a laser cut plate, there might be $5 worth or $10 worth or whatever, but it allows the community to get involved in what you're doing. I was just hearing some great examples in the city of Toronto of some parklets they're creating called raindrop parks, and they're specifically designed for school kids. And there's signage, and there's ways that they can watch the water flow and the water infiltrate, and they can understand how that water's being held on that site, and then how it's being used to support the growth of the trees that are growing in the pavement around. So if we can get the community engaged in what we're doing, because so much of it's buried, so much of it is under pavement and nobody knows about it, and we try and remember to go along and do some reporting on the tree health and the tree growth, but the community are vitally interested in this. I mean, this particular one has got a simple QR code, and if you click on that, the community can start engaging with the tree. The tree starts telling them what species it is, when it was planted, who are the innovative guys that put it there, what it's doing for this street, how much it's going to reduce the temperature in this street, the cleaning process with the water. These are all things that we can do, and I believe we need to do more of it. Future-proofing is a big thing that's come up. We believe it's really key to future-proof what we're doing, and it's a space that's been moving quite rapidly. And we believe quite strongly that we all need to realise that what we're putting beneath that pavement is a buried structure. And as step one, they should be registered with Dial Before You Dig, or First Call, and these authorities are around the world. We need to register with them that, hey, there's a buried structure of this type in this location. We can also use service locator balls. So we've done some work with 3M on service locator balls, which cost about $20 each, but you can load them with data, put them in the pit, and if somebody comes out with their service locator equipment, it'll throw up a signal. Another way would be to have a pavement marker, which can have a warning triangle, and that can take a service technician to a work method statement. It can take them to some after hours telephone numbers. It can even take them to some as-built drawings for the project, so they can actually see what's underneath before they start getting their equipment out and digging holes in the pavement. Pavement engineering and QA. So these are all what keeps us so busy at City Green, is supporting you in achieving healthy, sustainable tree canopies with stormwater harvesting. I've just got a few case studies here from around the world. So this is downtown Las Vegas. So we talk about rain events. Some parts of the world it almost never rains. So irrigation has to be included. But that's one part of the world where they had not been able to grow trees successfully. They now have got a flourishing tree canopy and are moving it forward. So essentially from the back of the curb to the building alignment is a vault of loam soil for those trees. Walt Disney is a firm that we've been doing some work with since about 2015. They had been using CU soil and they considered going to soil vault systems back then. The additional cost was a consideration, but they took the step and they're seeing incredible growth rates. So now they use nothing but soil vault systems for all the trees that they're growing in their theme park. So they're 4 Quercus virginianas in an interconnected soil vault matrix underneath that pavement. It's been a success story. One of our guys was on site today at one of their projects. So that's a client who recognises the value and the asset value of trees and a healthy canopy. This is one from this region, Dandenong, Lonsdale Street, Dandenong. It was a very interesting project. It seems to have been very successful. That's got quite a well-designed WSUD functionality to it. Those trees are in a system which captures rainwater, which is then filtered and goes off-site, and then is pumped back for irrigation. So that's the tree health there has been exceptional. This one here is a trial, and we love trials, and we'll support. We actually have a grants program which I'll send out later. But this was a gentleman who wanted to test his rule of thumb. He was a agroforester who went into urban forestry in Perth. And his rule of thumb was that for every 2 square metres of shade that he wanted to provide in 15 years from planting, he would give 1 cubic metre of loam soil at the planting and then monitor them, use the Burnley method of tree valuation as an asset on their books, and track them. Now, they're London planes. They went from being a 3-inch, 75mm stem caliper at planting to 250 millimetres in 4 years. It's pretty mind-blowing. It seems incredible that trees can grow that fast, but what we are seeing that trees can grow very quickly if they have the right growing conditions. On the left-hand side there is the same species that was planted 15 years earlier and valued by the same methodology. It's worth $510. So got out my trusty calculator and did crunch the numbers because something seemed wrong. But the facts are that they grew trees that were worth 34 times as much in 1/4 of the time frame. Now, it's incredible. The stats are there. We'll send you some information after this that tracks the asset growth over time. But it's a true story that if we get it right, if we get the volume right, if we get the soil quality right, we can start hitting our canopy targets much sooner than perhaps we ever thought we could. And this is a trial that our firm was involved with in North America. There's a large firm in North America called Bartlett Tree Experts. A gentleman called Dr. Tom Smiley put this together, where it's their soils under pavements test, where they wanted to test all available methods for growing trees beneath pavements. Unfortunately, it did not include stormwater harvesting. This was just about tree growth. And they tested a couple of soil vault systems, including ours. They tested gravel-based structural soil, sand-based structural soil. They had a control tree, and they repeated that 4 times over. And then, after 4 years, pulled them out. And Tom invited me over there for it, which I really enjoyed. It was a few days there at Charlotte, North Carolina. And incredibly messy, but a lot of fun. So what we were doing was the canopies removed, using hydrovac, using air spade, using pressure washers. We were carefully washing the soil away from those root systems. and exposing them, getting them out, making sure we gathered all of those fibrous roots. We want to capture everything we possibly could, and then weighing them. Bottom left, you'll see one of the researchers weighing the root mass. They were all tagged, photographed, catalogued, and put together in a report that's available now, and we'll send that out after this meeting. Essentially, all it proved was what a lot of us already knew, was that trees grow fastest in uncompacted loam soil. Where the soil is compacted, as Kate was saying earlier, you get that bulk density. I'm not sure if they got the Amsterdam tree sand mix wrong or what, but they were a very dismal failure. The gravel-based structural soil was similar. Best if you have a look at the report when it comes out. But what this is about is finding the ways to grow trees in the urban environment the fastest. Then if we couple that with the stormwater benefits that we've been hearing about, that's where we really start to get kicking goals as far as reaching canopy targets, as well as treating the stormwater in our cities, in our built environment. These are some of our industry partners across Australia, but I'd like to say thank you very much, and that's the end of my work.